You do need a calculator. So if you didn't grab your calculator, please go ahead and grab it. We're on page 548. Okay, the first thing you want to do is make sure that your calculator is in degrees. So go to mode and make sure it's in degrees like we did on Friday. Once you put yours in degrees, it should stay there unless somebody resets your calculator, because nobody in calculus is using those calculators, so you should be good. All right. So notice this is talking about oblique triangles. Oblique triangles are those triangles that are not right triangles. They can be obtuse, they can be acute, but they're not right. So, first off, do you remember from geometry what was the formula for the area of a triangle? Yeah. 1/2 base times height. And so if I had a triangle up here, this would be considered the base, and the height always makes a right angle to the base. So we can see on this oblique triangle that the height is drawn in as a dotted line. What's another name for the height? Does anybody remember?
Do what?
What's another name for the height? It's also called the altitude. Think of it as like height of the mountain, the altitude of the mountain. Same thing. And then they've labeled these sides here based on where they are compared to the angle. So like angle A, the side across from it is little a. Angle B here, the side across from angle B is little b. Angle C, side across from it is little c. So that's where they're getting those letters. So if I was going to use this triangle, I would define it as area equals 1/2. The base of this triangle is A, and I've called the height H. But those two mean the same thing. It's just we've labeled the sides differently. So now we want to do it so that we can find the height, because we won't always be given a right triangle. So we are going to say that B is AC. So this little b here is AC and it's 9. A is CB and it's 17, little a. And angle C is 67 degrees. And so the only thing we don't know for this formula is our height. So we don't know our H. So we're going to find that. So let's find H just using this right triangle. So using this right triangle, just the pink one, I have angle 67. I have this side B, which is 9. And which kind of side? Remember we talked about opposite, adjacent, hypotenuse. Which side would 9 be? Hypotenuse. It's across from the right angle, because if this is a right angle, then this one has to be a right angle also. So that's the hypotenuse. And the other side we need is H. So compared to angle 67, which side is H? Opposite. So thinking back to some old hippie caught another hippie tripping on acid, or whatever you want to call it. So Katoa, which trig function uses opposite and hypotenuse? Sine. So SOH, opposite hypotenuse. So S is sine. So I would write that as the sine of 67 degrees equals what over what? Opposite over hypotenuse. And which side's the opposite? H over 9. Good. Now what? Multiply by 9, or cross multiply either way. And you get H equals 9 times the sine of 67. And we're going to leave it like that for now. So that's our height. So to find the area of a triangle, it was 1/2 the side A for our triangle, and H. What's the length of little a up here? 17. And the height, the height is this. So 9 times the sine of 67 degrees. Now we can plug that into our calculator. It's going to give us the area of that oblique triangle. Always 3 decimals, please. Bless you. What'd you guys get?
70.419.
Yeah. I don't know what the units are. I'm just going to put square units. For area, it's always whatever the units are, meters, feet, whatever, squared. If they don't have it, you don't have to put the units there. But just kind of get in the habit. So now we're going to come up with a formula that we can use for an oblique triangle. Basically on what we just did up here. So we know the area is equal to 1/2. And then what we did up here was we took 17 times 9. So 17 times 9. Those are called consecutive sides because those sides come together at a point. So any two sides that come together at a point I can use. So 1/2 times the product, so that's when you multiply, of 2 consecutive sides. And then we took the sine, so it was 1/2, the 2 consecutive sides multiplied together, and then it says the sine of 67. Well, notice 67 is formed by those 2 consecutive sides. So it's the sine of the angle between the 2 consecutive sides. So that's the formula to find the area of any triangle, even if it doesn't have the height given to you. And so we don't have to find 2 steps, find the height first. We can just use this formula. Now, for our triangle that we had up there, I'm just redrawing it down here. You don't have to. I can use these letters to help me define it. The area could be 1/2 times AC, so the little sides A and C. Then it'd be the sine of what angle? So you label it with one letter. It's the side that is the angle that A and C form. B. Because A and C come together and make angle B. Or we could say, if we had, say, A and B, it would be the sine of what? C. Or we had, I guess it'd be B and C, then it'd be the sine of A. Yeah. So whichever way makes more sense to you. Fine. They all work. And they all do the same thing for us. Okay, so on the next page, it's talking again about an oblique triangle. And it has it labeled just like before. It says, using angle C, we want to find an expression for H in terms of B. Okay, so we're not doing area, we're just talking about H and whatnot. So angle C is here. H is here, which is the opposite side. And B is here, which we said was the hypotenuse. Good. So that was the sine of C, right? That's what we just did, only we had numbers in there. Equals the opposite over the hypotenuse. So to solve for H, cross multiply. H is B times the sine of C. You're going to see where this is going in a minute. We're going to derive a formula. We're going to come up with a nice, neat formula. So now let's look at angle B. And we want terms of C and H. H, again, is still the opposite. What side's C? Still the hypotenuse. It's just a different triangle, right? So again, it's sine. Sine of B equals opposite over hypotenuse. Put that over 1, cross multiply. You get H equals C times the sine of B. But we could do that one more time. Do it with A. Little a and big A. So if both of the expressions above are equivalent to H, then obviously these two have to be equal to each other, right? Because if they're both the height of this triangle, then those two sides or those two expressions have to be equal to each other. So we're going to write that. We know that the B sine of C is equal to C sine of B. And notice when I'm talking about a big letter C or a big letter B, then I'm talking about the angle. Talking about little a, b, or c, then that's the side. To get our equation that I'm wanting us to get, I'm going to divide both sides by the same thing. I'm going to divide both sides by little b and little c. So on the left, the b's will cancel. And on the right, the little c's will cancel.